Hello dear friends, and welcome to this video today on our YouTube channel. In this video, friends, we shall be looking at how we can determine the focal length of a converging lens. So friends, stay tuned and watch the video from start to finish, because at the end of this video you shall be able to walk into the physics practicals, into the physics laboratory, and carry out this experiment without any ease. And friends, please, it took me a lot of time to prepare this video for you, so please do consider giving the video a like, giving it a thumbs up, and subscribe to our channel if you're not subscribed, so you're going to have all latest updates about good content that can help you in your exam, and how can also help you to progress in your life as a scientist. So friends, let's dive straight into our video today. So as you can see, the question is saying that you're provided with the following: a light source, that is a lighted candle, a converging lens in its stand, a screen, and a metal roll. Then the question wants you to determine the focal length of a converging lens, of the lens that has been provided. So friends, as usual in the physics practicals, we start by bringing forth the diagram of setup. In this case, friends, we need a screen. Everything has been provided normally. That's if the apparatus was not provided, we need a screen. We need a candle like they've given us, because the candle is what is going to give us the light source, or any light source, guys. But in this case, the candle has been provided. Then we need the lens in its holder. Great. So friends, in this case now, in most of the times in the physics laboratory, they always ask you to use your question paper, because this whitish. They always ask you to use your question paper as the screen. Okay, as the screen. So let's start, guys. We are going to have this is simply going to be the floor where we are going to do the practicals. Then we are going to have our screen of this form. Then now, guys, we are going to have the stand. We are now going to have the lens, which is on the holder. Good. Then now, guys, we are now going to have our candle, and we have the flame that is on the candle. Great. Then friends, now you're now going to have the image distance. Then we're now going to have now the object distance, that is the distance from where our light source is to the candle, because this is our object distance, of which the candle in this case is acting as what? As our object. Okay, the light source from the candle is acting as our object. Then now this our V now is our image distance, which is simply the distance from the center of this our screen, the center from this lens now to the screen. Good. So we can just see, we can indicate some sharp image, friends. Great. That's one sharp image. So friends, the basis of this practical is that once you must have made your setup of this nature, having the lens in between the light source and the screen, you're going to be adjusting the lens until you see a very sharp image on this screen. Once you've seen the sharp image of this your light source, the image normally, guys, it's inverted, right? It must be an inverted image, because if we can draw for the array diagrams, you see that it's an inverted image. It's an inverted image. Great. So friends, we are going to see an inverted image of this our light source on the screen. Once we must have seen that very sharp and inverted image, we simply measure this distance from the screen to the lens. We call that our V. Then the distance from the lens now to the light source, we call that our U. This U will serve as the object distance. Then V serves as the image distance, from which we can use the lens equation now to calculate the value of the focal length. Good. So friends, let's start with our procedure. As usual, our procedure is going to read that the apparatus is as shown above. The lens on its stand was moved towards or away from the screen. Good. So friends, let me just explain. Once the apparatus has been set up in this form, now we are going to move the lens either towards the screen or away from the screen. It depends on how we can see this sharp image, because sometimes when you move the lens towards the screen, the image you see appear to be blurred. Okay. Then now sometimes when you move it towards the source, now it now appear to be shiny, and it gives you the sharp image. Good. Until the sharp image of the flame was from the burning candle was seen on the screen. The lens from the lens to the candle, and from the screen, that is the lens from the lens to the candle, that is this our U distance, and from the screen and from the screen to the candle, that is this our V, were measured using a meter rule. Good. So friend, this is all about the procedure, which is very short and easy to remember. As you can see guys, it's very short and easy to remember. This is all about the procedure. Good. Then now friends, for our observations, we need the observations. As usual, our observations are just going to be the value of V and the value of U we just measured. So we are going to have our U in this case to be 24.0 centimeters. I've just taken U to be 24.0, okay, 24.0. Then I've taken my V to be 20.0, though according to the distances, this guy is rather so much than this guy, okay. It's an experimental error, don't bother. In the exams, you're going to measure it accurately. Good. So these are our observations. These are the values that we are going to get from this experiment. Then now friends, let's now go to the calculations. Let's go to the calculations. We are going to tell them that that from the length equation, 1 over f equals 1 over v plus 1 over u. Keep in mind friends that I've defined the values of v and u already, right? Because these are the distances I indicated here. I must not write them as sentences. I've indicated them as this distance here. All I need to do now is to define what this f means, because I told you guys initially that in physics it is so important to define symbols, because so many symbols can mean something else, okay. So we must define what this f is. So we'll tell them that where our f is a focal length of the lens. Good. F in this case is the focal length of the lens. That therefore means that guys, if we make f the subject, we are still going to have our f to be uv all that over u plus v. Good. So we cross multiply and divide by the LCM. Then since we have 1 over f, now we now invert. We have uv over u plus v. That therefore implies we are now going to have our f to be, we substitute all the values, we are going to have this as we have. Then now if we punch our calculator guys, we expect to see an answer of 10.9 centimeters. Guys, let's keep in mind that the focal length sometimes is being measured, okay, it's been measured. So, and like I said initially, like I was emphasizing in all my videos, that this distances you're measuring, you're using the meter rule, and the meter rule can only give you distances to 1 decimal places and in centimeters. So this focal length as well, it's a distance, and it should be to 1 decimal place. Good. So friends, this is what we have. Then now we can go now to our precautions. We can tell them that for our precautions, we are only going to measure the value of u and that of v only when we see a sharp image here. That is it, because sometimes what most people do is that the moment they see any image here, they just measure. It's not good, friends. We have to adjust it so well until the sharpest image of this candle. That sharp image must not be blurred. It should be very intense but sharp, until a sharp image of the source is seen on the screen. Good. So we would simply tell them that u and v were only being measured when the sharpest image was seen on the screen. Good. Then now friends, our conclusion is simply going to be the value for the focal length that we have is going to be 10.9 centimeters. Good. So friends, that's it. Friends, an important note I want you to take that under normal circumstances, the focal length of guys of a converging lens is positive, okay, is positive. That for a concave lens or a diverging lens is what is negative. A converging lens is also called a convex lens, okay. It's also called a convex lens. You can go to example and what it tell you is a convex lens. It is still the same thing, okay, it's still the same. So a converging lens is the same like a convex lens, and a diverging lens is the same like a concave lens. So never forget. And like I said initially, friends, that the focal length of a convex or a converging lens has a positive value, that for a diverging lens has a negative value. So friends, thank you very much for watching the video, and don't forget to give the video a thumbs up, because it took me quite a lot of time to prepare all this for you. My aim is to make sure that all of you pass your practicals so well and in good grades. So don't forget to subscribe to the channel if you've not subscribed, because we are going to be uploading so many interesting contents here for you. You can afford to miss. Thank you very much guys, and good luck as you prepare for your exam. Stay blessed and have a great day.